What if I told you space doesn't actually begin where most people think it does? Where does Earth truly end? And where does space really begin? This is a complete cinematic journey from Earth's surface to the edge of the universe.
We will travel layer by layer, escaping gravity step by step into the vast unknown.
Our journey begins here, on the only known planet that supports life. This first layer is the troposphere, where all weather and life exist.
Surprisingly, Earth's atmosphere is thinner than the skin of an apple.
Every storm, cloud, and breath of air exists within this fragile lower layer.
Compared to Earth's size, this life-supporting layer is incredibly thin.
As we climb higher, we enter the stratosphere, a calmer, colder region.
This layer contains ozone, silently shielding life from harmful solar radiation. Billions of years ago, volcanic gases slowly formed the atmosphere we rely on today. This is the mesosphere, where meteors burn before reaching Earth. Every day, thousands of space rocks vanish here, protecting our planet. Temperatures here can drop below -90 degrees Celsius. Now we reach the thermosphere, home of the breathtaking auroras.
This is where astronauts live and orbit inside the International Space Station.
Most people believe space begins exactly at 100 kilometers above Earth.
But the truth is, space does not suddenly start at a sharp line.
As we go higher, the atmosphere fades, and the real definition of space becomes far more complex.
We have now entered the exosphere, the outermost edge of Earth's atmosphere. Here, air molecules are so sparse, they can travel hundreds of kilometers without collision. This proves a hidden truth. Space doesn't begin at a sharp border.
In reality, space begins gradually, as Earth's atmosphere slowly disappears into the vacuum. Even here, Earth's gravity still holds everything within its invisible grip.
This region is called low Earth orbit, where satellites circle the planet at incredible speeds.
To escape Earth, rockets must reach speeds faster than gravity can pull them back.
This critical speed is called escape velocity, nearly 11 kilometers per second.
And beyond the atmosphere, sound itself cannot travel. As gravity weakens, astronauts experience microgravity, a state of near weightlessness. In orbit, spacecraft travel over 28,000 kilometers per hour to stay above Earth.
Commercial airplanes fly at just 10 kilometers, while orbit begins hundreds of kilometers above.
From this height, Earth transforms into a glowing blue sphere in the darkness. The sky turns black because there are fewer particles to scatter sunlight.
Now we move beyond crowded orbit, into the true vastness of space.
Surrounding Earth are the Van Allen belts, trapping dangerous cosmic radiation. This magnetic shield protects life from the sun's deadly charged particles. Without an atmosphere, Earth would be silent, freezing, and exposed to cosmic radiation. As we travel farther, Earth begins to look like a tiny oasis in an endless void. Our journey is only beginning, because beyond Earth's orbit lies the gateway to deep space. Just beyond Earth's orbit lies our closest cosmic neighbor, the Moon.
Unlike Earth, the Moon has no atmosphere, no weather, and no sound.
While Earth protects life with air and water, the Moon remains exposed to space.
Scientists believe the Moon formed after a massive collision billions of years ago.
The Moon orbits nearly 384,000 kilometers away from Earth.
From the Moon, Earth appears as a fragile blue marble rising in darkness.
As we move farther, even the Moon becomes just another object in the vast void.
This region between Earth and the Moon is called cislunar space.
Here, the Sun's gravity begins to overpower Earth's gravitational hold.
For the first time, Earth and Moon look like tiny dots in an endless universe.
We are now entering the realm of the solar system, governed by the Sun's immense gravity.
Planets orbit the Sun because its gravity bends the very fabric of space. Earth travels nearly 150 million kilometers from the Sun in its orbit.
Human-made probes continue traveling far beyond Earth's boundaries into deep space.
Despite billions of galaxies, space is mostly empty beyond imagination.
If the Sun suddenly vanished, Earth would freeze within weeks. We now pass through the asteroid belt, a field of ancient rocky remnants.
Contrary to popular belief, asteroids are millions of kilometers apart.
The farther we travel, the more our solar system reveals its enormous scale.
And beyond this point, we approach the cold, mysterious frontier of the outer solar system.
We are now entering the outer solar system, where sunlight grows faint and temperatures plunge.
Jupiter, the largest planet, is so massive it could swallow all other planets combined.
Over 1,300 Earths could fit inside Jupiter's enormous volume. Jupiter's radiation belts are among the most dangerous environments in the solar system.
Saturn's rings are not solid, but made of countless icy fragments orbiting in harmony. Inside the rings, particles range from tiny grains to massive boulders. Out here, the Sun begins to look more like a bright star than a blazing giant. These icy giants exist in extreme cold, far from the Sun's warmth.
Temperatures here fall below -200 degrees Celsius.
Beyond Neptune lies the Kuiper Belt, a distant region filled with icy remnants of planetary formation.
Dwarf planets like Pluto orbit in this distant frontier of our solar system.
Our solar system is so vast that light itself takes hours to cross it.
The heliosphere is a protective bubble formed by the Sun's solar wind.
At the edge of this bubble, the Sun's influence finally begins to fade. Human probes like Voyager have already crossed into interstellar space.
This boundary is called the heliopause, where interstellar space truly begins.
From this distance, Earth becomes just a tiny, pale blue dot in the cosmos.
The distance to the nearest star is thousands of times greater than the size of our solar system. We have now entered true interstellar space, the vast region between stars.
And beyond interstellar space lies the immense structure of our galaxy. We now witness our home galaxy, the Milky Way. Our solar system lies in a quiet spiral arm, far from the galactic center. At the center of our galaxy lies a supermassive black hole. Its gravity is so strong that even light cannot escape. Our galaxy alone contains over 100 billion stars.
And yet, there are billions of galaxies beyond our own. The universe itself is expanding, stretching space in every direction.
On the largest scale, galaxies form a vast cosmic web.
If we could travel faster than light, we would still take ages to cross the universe. There is a limit to what we can see, called the observable universe.
This faint radiation is the afterglow of the universe's birth. Compared to the universe, Earth is smaller than a grain of sand.
And yet, every Hispanic human story ever lived exists on that tiny world.
Now, let us return back to where our journey began. Our galaxy grows larger as we approach our quiet spiral arm. Our sun comes back into view, a single star among billions. And there it is, our home, suspended in darkness.
From the edge of everything we can observe, Earth is just a fragile blue light.
That thin atmosphere we crossed at the beginning is all that protects life.
From Earth's surface to the edge of the universe, this entire journey reminds us of one truth.
In the infinite cosmos, our small world is unimaginably precious.